I want to do a few simple examples using solving equations that have variables in the exponents. And when that happens, basically 5 to the x equals 625. There must be a way to rewrite 625 as some other number. So think about it for a second. Basically, if you don't know this, you can use your calculator, just play with the number 5 to different exponents. But 625 is 5 to the 4th. So I could rewrite this as 5 to the x equals 5 to the 4th. Now at this point, I bet you could deduce that x must equal 4. And there we solved a little algebra equation. So this section, 35 to 38, they're a little more difficult than this, but I'm going to do now a problem that's a little bit harder. Let me take a second to write it down. So you'll notice this one is a little bit more difficult. There's a lot more happening in the problem. The first thing you want to do is try to get the whole problem in the same base. In this problem, 5 was the base on this side, so I tried to figure out if I could write 625 as 5 to some exponent. So here I have 3 to an exponent, 9 to an exponent, and 3 to an exponent. So I need to rewrite that 9. Do you know what I could write that as? Hope you said 3 squared. So let's do one more step. So I have 3 to the 6n. We're not changing that yet. Then I have 3 squared, squared, and 3 to the 3n to the 3rd. Now, in terms of exponent rules, you know the rule for power to a power, right? Do you add or multiply? Hope you said multiply. Okay, so 3 to the 6n equals 3 to the 4 times 3 to the 9n. You follow how I got that? All right, next, how do I combine these two parts? I'm going to keep this side 3 to the 6n, but what am I going to do here with these two? The bases are the same, so what do I do with the exponents? I add them, so now I have 3 to the 4 plus 9n. I really can't add that, but I show that I want to add it. Now, if this equal sign is true, that means that this exponent, 6n, must equal 4 plus 9n. So there I have a basic little algebra problem to solve. So I set up 6n equals 4 plus 9n and just solve it. So let's subtract 9n from both sides. That part's easy, right? Subtract 9n. So now I get negative 3n equals 4. Continue solving for n. What do you think I should do? Yeah, divide by negative 3. So n equals negative 4/3. And if you put that in on both sides and check that out, you'll end up getting 3 to the negative 8 equals 3 to the negative 8. So we know that our n is correct if you check, plug it in on both sides. I'll leave that to you. So the problems you have to do, 35 to 38, look at the base numbers. And first thing you want to do is get all the bases the same. Usually you're going to use either 3s or 5s or 2s are most often used, right? So if I gave you a number 27, how could you write that? 3 to the 3rd. If I gave you a number 8, how would you write that? 2 to the 3rd. If I gave you a 16, how could you write that? You could write it as 2 to the 4th, right? Or 4 squared, depending on what bases are in the problem. So you should be able to do page 173, 35 to 38 now. Good luck.